So today's chapter is vector algebra. So for that we need to know what is a vector quantity and what is a scalar quantity. So what is a vector quantity? It is a quantity which has both magnitude and direction. A quantity, a physical quantity which has both magnitude and direction. Magnitude and direction. For example, if a person is moving from here to here in the direction like this, so it becomes a vector quantity. So what are the examples of vector quantities? Those are displacement, velocity, acceleration, etc. So these are called vector quantities. Similarly, what is a scalar quantity? A scalar quantity is a physical quantity which has only magnitude. So a scalar quantity is a physical quantity which has only magnitude. For example, distance, speed, time, etc. So what is a vector? A vector is a directed line. A directed line means a line segment which has some direction. So this is a vector, this is also a vector, this is also a vector. So we will write this point as A and this point as B. So for us, AB is a vector. We will denote it like this. And the length of the line segment is the magnitude. So magnitude of the vector AB is denoted like this, AB vector and this. So this becomes the magnitude of a vector. So here this A point is called initial point and this B point is called the terminal point. That's the terminal point. And what is a scalar? A scalar is just a number, only the magnitude, no direction. So scalar in mathematics, it is just a number. So now we will discuss types of vectors. So first type is zero vector, zero or null vector. From the name itself it says zero vector means the magnitude is zero. A vector which has no magnitude. But since it's a vector, so it has some direction. It is denoted as zero vector. So it is a zero or null vector. Next is unit vector. What is a unit vector? Same, from the name itself, a vector which has magnitude 1 and is denoted as some vector A, then a cap. So it is read as A cap. So what is a cap? A cap, the value becomes the value is vector A divided by its magnitude. So we can always find out a unit vector along any vector. So next vector is co-initial vectors. Co-initial vectors. Two or more vectors are said to be co-initial if they have same initial point. So if they have same initial point. So it look something like this. These type of vectors are called co-initial vectors. Next is equal vectors. Two vectors are said to be equal if they have same magnitude and same direction. Same magnitude and same direction, like this. Next, we will know what is a position vector. So, if a point is like this, it is in 3D. So this is x-axis, y-axis, z-axis. X, Y, Z, they are perpendicular to each other, and if there is a point A in the 3D, so what is its position vector? This is the origin, and we will join the A point to the origin, and the direction will be towards A. Why? Because origin is the starting point of everything, so this will be initial point and the direction will be towards A. So OA is the position vector of A. So OA becomes position vector is the position vector of point A. So we can always find out the position vector of any point. So that means every point in 3D is a vector. So now we will study what is addition of vectors. So for that we have two laws. First law is triangle law of vector addition. Triangle law of vector addition. What it says? It says if a person is walking towards this direction and covered this distance, and then he changed his direction from this to this and walked in a direction in this distance. So what will be the addition of this and this vector? Suppose this vector is vector A and this vector is vector B. So what will be the direction and the magnitude of the sum of the two vectors? So this will be represented by the third side of the triangle, and the direction will be like this. So this vector is A plus B. So this is called the triangle law of vector addition. What is triangle law of vector addition? If two vectors are represented by the two sides of a triangle taken in same order, this and this is anti-clockwise, taken in same order, then their addition will be given by the third side and the direction will be in the reverse order. So this is the reverse order. So now we will discuss parallelogram law of vector addition, and what it says, if there are two co-initial vectors like this, let's say this vector is vector A and this vector is vector B, so what will be their sum? We simply cannot just join the third side and make it vector A plus B. We cannot, because the direction of the two vectors are different. It is not clockwise or anti-clockwise. So we cannot use the triangle law of vector addition. So what we will do? We will draw another vector which is parallel to vector B and it has the same magnitude as vector B. And again we will draw another vector which is parallel to vector A and magnitude is same as A. So it looks like a parallelogram. Since this is the vector B and this has same magnitude and same direction, so it is an equal vector, so it is also vector B. So this direction is like this and this direction is like this. So from triangle law of vector addition we can say that their sum is given by this, and this one becomes A plus B, and the direction will be like this. So what parallelogram law say? It says if two vectors A and B are represented by two adjacent sides of a parallelogram then their sum will be given by the diagonal of the parallelogram which is co-initial with them, Next is components of a vector. So let's say we have 3D. So let's say we have a point A here in 3D. So this is x-axis, y-axis and z-axis. So since it is a point, it has some coordinate, let's say x, y, z. So what is x, y, z? X, y and z, they are if we are drawing a perpendicular from the point A to x-axis, so from origin to this distance it is x. Same for y also, if we are drawing a perpendicular on y-axis, from origin to this distance it is y, and same goes for z-axis also. So this is x and y and z, which is the coordinate of this point A. Now let's just see what is A cap. What is a unit vector? As we have already studied, a unit vector is the vector itself divided by its magnitude. So from here we have concluded that the vector is nothing but the unit vector multiplied with its magnitude. So the vector can be represented as its unit vector, the unit vector along that vector and its magnitude. Now we will introduce I cap, j cap and k cap. They are unit vectors. So the magnitude of them is 1. They are unit vector along x-axis, y-axis and z-axis. So they are unit vectors along x-axis, y-axis and z-axis. So this one is I cap, this one is j cap, and this one is k cap. So as we have seen that a vector is nothing but the unit vector and the magnitude of that vector. So we are writing OA vector as x I cap plus y j cap and plus z k cap, where x, y and z are this intercepts and I cap, j cap, k cap are the unit vectors along x-axis, y-axis and z-axis. So any point in 3D is a vector, as we have already discussed. So if a point is given like this 1, 2 and 3, so what will be the components of the vector? So the vector is OA vector, the position vector of A, and its components are I cap plus 2j cap plus 3k cap. So any point can be written like this.